Hi there! In this part, we want to demonstrate how to break down a single force into the vertical and horizontal component. We will first do so on a graphical approach, followed by the analytical approach. What is our situation? We have a force of 50 Newton that acts at a 30-degree angle to the horizon on a beam. And our goal is to determine the component on the x-axis and the component on the y-axis of this force. To do so, you first need to draw a y-x coordinate system. Okay, and now let's label the axes. Okay, now you want to insert the force vector into the positive area of the y and x coordinate system. So that's going to be here at the bottom right corner. Let me do that. So I'm going to insert the force vector, and remember that the angle between the force and the horizon is 30 degrees. Okay. I'm going to first show you how to determine the components geometrically and then how to calculate them mathematically. So, to determine the components geometrically, all you need to do is to draw a line that is parallel to each axis, and the parallel line needs to touch the tip of the force vector. Let me show you. So, for the x component, or for the x-axis, you're gonna draw a line that is parallel to the x-axis, and that line needs to touch the tip of the force vector. It's gonna look like this. Okay. And you do the same thing for the y-axis. For the y component, you draw a dashed line, or a line, that is parallel to the y-axis, and that line needs to touch the tip of the force vector. Okay? And your x and your y component is simply the length of that line, in my case, the dashed line between each axis and the tip of the force vector. So, for the x component, that's going to be, that's going to be this force component arrow. Okay, so the length of this arrow represents the x component of the force. And for the vertical component, that's going to be this force vector. So I'm going to label them as f sub x to indicate that this is the x component of the force, and this is the y component of the force. Once again, the length of each force component is determined by the distance along the dashed line in the respective direction between the axis line and the tip of the original force vector. Now, as I said before, there is a geometric and a mathematical approach to computing the magnitudes of the force vectors. Let's start with the geometric approach, and that approach involves drawing the force vectors true to scale. In other words, you need to make sure that the length of the force vectors reflect their magnitudes. So let's establish, for example, that 1 centimeter on paper or on the tablet is equivalent to a force magnitude of 10 Newton. In that situation, you would need to draw your main force vector at a length of 5 centimeters, which corresponds to a force magnitude of 50 Newton. So let me write down 50 Newton is equivalent to a distance or to a length of not 5 meters, but 5 centimeters. Okay, because we've established that 1 centimeter is equal to 10 Newton. And if you have done that, then all you need to do is to measure the lengths of Fx, of this arrow, and of this arrow using your ruler. And if you have drawn the force vectors correctly, then you should come up with the result that says that your Fx is equal to 4.3 centimeter, which is roughly 43 Newton. And your Fy should be 2.5 centimeters, which is equivalent to 25 Newton. Okay? Now, the problem is that when you write an exam, you most likely don't have either a ruler or you don't have enough space on the paper so that you could draw forces true to scale, especially if the contrast between forces is quite huge. And in that situation, you need to resort to the mathematical approach. The mathematical approach involves performing some trigonometric operations on a right-angled triangle. If you look closely at our forces, Fx and y and F, you will notice that they shape a right-angled triangle. Let me draw them one more time in a right-angled triangle to highlight that. So I'm going to start with Fx, and then continue with Fy. And I'm going to connect them with the original force F. So as you can see, these forces form a right-angled triangle with the right angle being here. And remember, we have our angle of 30 degrees to the horizon. And now, if you want to calculate Fy, when you have F, you just use the sine. So Fy is equal to F times the sine of 30 degrees. Why sine? Because a sine is defined as the ratio of the opposite leg and the hypotenuse. In our case, the opposite leg is Fy and the hypotenuse is F. So the sine of 30 degrees is going to be Fy divided by F. And if you want to rearrange that equation into Fy, then you have F times the sine of 30 degrees. And let me complete that equation. So F is 50 Newton times the sine of 30 degrees, and that's going to be 0.5. And that is equal to 25 Newton. So basically what we have measured above. And now this value is absolutely precise. So you don't have to worry that you might not measure a length precisely enough. Okay? And to calculate Fx, you're going to go to use the cosine. The cosine is defined as the ratio of the adjacent leg and the hypotenuse. In our case, the adjacent leg is Fx and the hypotenuse is again F. So rearranging that equation into Fx is going to give us F times cosine of 30 degrees, and that's equal to 50 Newton times 0.866. If you round it to 3 decimal places, and that is equal to 43.3 Newton. So that's the exact value of the x component of the force. that looks quite simple on paper or on this video, but what if you're not that good at trigonometry? And what if you struggle to memorize when to use sine or when to use cosine? Or, what to do when you simply forget what sine and what cosine refer to. In that situation, I have a good mnemonic for you. And that mnemonic says cosine, use cosine for the considered axis. I'm going to explain in a second what I mean by that. So, let's say you have an angle between F and an axis. I'm not going to be specific right now on which axis. I'm just referring to any axis, either y-axis or x-axis. So let's assume you have your angle between F and an axis, and you want to compute the component of the force along that axis. In that case, remember that cosine stands for considered axis. Okay, that means that, for example, if you have an angle between F and the x-axis and you want to calculate the x component of the force, use cosine in your formula. If you have an angle between F and the y-axis and you want to compute the force along the y component, basically the component of the considered axis, then use cosine. And let me show you an example on how you can apply this mnemonic. So if I have a coordinate system and I have a force which has a magnitude of 50 Newton as well, okay, and I'm gonna draw that force at an angle of just 15 degrees towards the y-axis. Okay, now what do we have? We have an angle between F and the y-axis, or if you're looking for the force component along that axis, then you're gonna have Fy. Let me draw Fy with the green color. So that's gonna be your Fy. And if you're looking for the length or for the magnitude of Fy, then you have an angle between F and Fy, your considered axis, as I say, and for considered axes, use always cosine. And let me perform the calculation. So we have Fy is equal to F times cosine of 15 degrees. And that's equal to F is 50 Newton times cosine of 15 degrees. And that is equal to 48.3 Newton. Okay, so remember, that mnemonic is going to be quite helpful. And if we apply this mnemonic to our previous calculation, well, you can see that our angle of 30 degrees is an angle between F and Fx, or x, both Fx and x run or show in the same direction, and that's our considered axis because that's the axis that encloses the angle together with the force F. Okay, so in that situation, use the cosine mnemonic, And as I showed you, to compute the component of the force in the axis that we consider, in other words, the x-axis, then we also use the cosine. Okay? And by the way, if you want to verify that you did your math correctly, then all you need to do is to basically perform the calculation backwards and use Pythagoras theorem as shown in the first video to to find out your f. And if your f is the same as originally, as 50 Newton in our example, then you did your math correctly. Okay, so I hope I could help you in better memorizing when to use cosine, and I'll definitely talk more about how to split forces in the next video.